Column Chromatography. Presented by Dimagiba, Magudayaw, Potes, and Sanyes. Developed by M.S. Twed, the Polish botanist. In 1906, he used absorption column in his investigation in plant pigment. Column chromatography. This is one of the most useful methods for the separation and purification of both solid and liquid. This is a solid-liquid technique in which the stationary phase is a solid and the mobile phase is a liquid. Principles of column chromatography. Adsorption. The mixture of the components dissolved in the mobile phase is introduced into the column. Components moves depending upon their relative affinities. What is adsorption? It is the adhesion of particles on free surfaces. The phenomenon of attracting and retaining the molecules of a substance on its surface by another substance. Adsorption in column chromatography. The absorbent pack in a glass column and a solvent, the mobile phase that moves slowly through the packed column. A solvent used as a mobile phase is called eluent. Adsorption in column chromatography. A compound attracted more strongly by the mobile phase will move rapidly through the column. The column dissolved in the eluent will come off. In contrast, a compound that is more attracted to the stationary phase will move slowly through the column. Adsorbents employed in the column chromatography. Silica gives good result with compounds containing polar function groups. Alumina, suitable for chromatography of less polar compounds. Calcium carbonate, calcium phosphate, magnesia, starch. Following criteria that should meet the column chromatography. Particles should be spherical in shape and uniform in size. Mechanical stability must be high. Should not react chemically. Should be useful in separating for wide variety of compounds. Should be freely available and inexpensive. Particle size of commercially available grades is in the range 50 to 200 micrometer. The choice of solvent depends on the solubility characteristics of the mixture. The solvent should also have sufficiently low boiling points to permit recovery of the eluated materials. Here are the different mobile phases used: petroleum ether, carbon tetrachloride, cyclohexane, ether, acetone, benzene, toluene, ester, and water. Column characteristics. The main function. Support stationary phase. Column dimension. Length and diameter ratio. 10:1, 30:1, or 100:1. Various accessories are attached to the column for maintenance of the elution process. Material of the column. mostly good quality neutral glass since it should not be affected by the other solvent. An ordinary burette can also be used as a column chromatography. Parts of column chromatography. It is composed of ground glass joint, solvent level, solvent bulb, sand, column, cotton, and stopcock. For the procedure, a mobile phase is used for the movement of the component mixture through a stationary phase. By the column chromatography, different sample component possesses different affinities towards the mobile and stationary phases. They emerge from the stationary phase at different times. Generally, silica or alumina is used as the stationary phase in the chemical laboratory. Thick white slurry is then produced by mixing the stationary phase with the solvent. To maximize the sample separation, a liquid mobile phase is chosen. This liquid either can be water or any organic solvent. Elution. Eluting the component compounds of the sample from the chromatography column is done by a process in which compounds are washed through a column by using a solvent. The preparation of the column. Consists of a glass tube with bottom portion of the column packed with glass wool or cotton wool or may contain asbestos pad, above which adsorbent is packed. After packing, a paper disc is kept on top so that the adsorbent layer is not disturbed during the introduction of sample or mobile phase. Glass wool prevents solid material from flowing through the stopcock when open. Sand provides level surface on which to build the silica column. Solvent protects the sand layer from being disturbed when slurry is added. Slurry, stationary suspended in a solvent or a mobile phase. There are two packing techniques, the dry packing and wet packing. Adsorbent is packed in the column dried form. Fill the solvent till equilibrium is reached. Demerit, air bubbles are entrapped between the mobile phase and the stationary phase. Cracks appears in the adsorbent layer. After filling, topping can be done to remove the void spaces. Wet packing technique. Ideal and common technique. Stationary phase settles uniformly and no crack in the column adsorbent. Development technique. By elution technique, the individual components are separated out from the column. In isocratic elution technique, this elution technique, same solvent composition or solvent of same polarity is used throughout the process of separation. For example, chloroform. In gradient elution technique, the solvent of gradually high polarity or high elution strength are used during the process of separation. For example, benzene, chloroform, ethyl acetate, and chloroform again. Detection of components. If compounds separated or colored, the progress of the separation can simply be monitored visually. If it's colorless, small fraction of the eluent are collected sequentially in labeled tube and the composition of each fraction is analyzed by TLC. Eluting the sample. Components A, B, and C separates as column progresses. Fractions can be collected in the test tubes, vials, beakers, or Erlenmeyer flask. Analyzing the fractions can be done by thin layer chromatography. Here are the advantages of column chromatography. Any type of mixture can be separated. Any quantity of mixtures can be separated. Wider choice of mobile phase and automation is possible. The disadvantages are time-consuming, more amount of mobile phase are required, automation makes the techniques more complicated and expensive.